In today's video, we will be discussing Physics 251 Week 7 Video Explainer problem number 43. In this problem, we are asked to relate some tensile forces between two different funicular cars on a mountain in Chile. So for this problem, if you feel uncomfortable at any point, I recommend turning back to the Week 7 lecture, where you can look at pages 27 through 45, which give you a good idea on how to use tensile force and kind of solve equations pertaining to that. So let's go ahead and get into the problem. So I've underlined some of the things that I thought were important, such as a large pulley is connecting the two funicular cars, one of which is being pulled by a small motor. I've also underlined the mass and the coefficient of friction of the car, and the fact that the cars are moving at a constant speed. So here we are given our drawing to kind of put a mental image of what's going on, and this is given to us, by the way. So I've gone ahead and called this car, the car that's moving upwards, car 1, and I've called the car that is moving downwards, car 2. So I've drawn diagrams kind of relating all the different forces together for each of the cars here. For car 1, we have the normal force, the tensile force from the motor, the pulley, the tension force from the pulley, and the force due to gravity, as well as the frictional force for the upward moving car. For the second one, pretty much everything is the same, except now we have the frictional force in the downward direction car, and the just the pulley force, because we don't have a motor attached to this car. So when we're thinking about how to solve this problem, we want to kind of see if there's a way that we can relate the equations for the forces to kind of solve for an equation, if you will. So for example, we can kind of think of it as summing up the forces in the y direction and in the x direction, and then kind of comparing across the two cars and substituting out where we have variables or where we don't have variables. So if we do that, we get that our forces on the car 1, this would be in the y direction, and this would be in the x direction. And of course, when I'm saying y direction and x direction, we have to take into account the fact that the slope is at a 35-degree angle, so I'm obviously going to be solving some of the trigonometric expressions to kind of mitigate the fact that it is in fact on a slope. So I did this for both car 1 and car 2. And then, so what we want to do is, when we're trying to find the tension in the connecting cable, we want to try to just solve it for car 2, because car 2 does not have the force from the motor, so we can just solve for the pulley force. So as you can see, I'm plugging in from A1 here, and I'm plugging A1 into our frictional force equation, which is the coefficient of friction times the normal force. And then I'm plugging this into our A2, which is our forces in the x direction, which leaves me with this equation for tension right here, in which I can solve and get 8.2 times 10 to the 3 newtons. For part B of the problem, I'm going to be doing the same thing, except I'm going to be trying to solve for this tensile force here in the first car. So exact same setup, taking B1 and plugging that into the frictional force relationship, and then substituting that into B2. From here, I can kind of rearrange the equation and solve for Tm, or the tension from the motor, in which I get 482.15 newtons. So that's about it for this problem, and thank you very much for watching. I hope this was helpful.